So in this question, we're told that for a given right angle triangle, the opposite side is x centimeters and the adjacent side is x plus 3 centimeters. So we know that the opposite and the adjacent are two names for the smaller sides in a right angle triangle, and the hypotenuse, which we know is the longest side, is going to be 13 centimeters, and we're asked to find the value of x. And so what I'm going to do is just start by drawing a diagram. So if we have one side which sort of comes down from the top, so I just straightened it up there a bit, and then another side which kind of goes out to the right, so we can say that the shorter one of these two is going to be x, and the other one is going to be x plus 3, and then we just connect the kind of endpoints of these two sides. So we have our hypotenuse. We know that our hypotenuse is going to be 13 centimeters, and so this is how our diagram is going to look. Because we're told that x is the opposite, technically we would have an angle in here where we know the x is opposite that angle, but it's not too important once we actually get our triangle drawn correctly. And so we know that the right angle is going to be in here between the smaller two sides, opposite the hypotenuse. And so now we can actually set up our theorem and figure out what the value of x is. And so as always with Pythagoras' theorem, we want to square the smaller two sides. So we're going to have x squared, and just be careful with your x plus 3 because we need to square all of it. So we are going to be expanding that bracket there in a second. And this is going to be equal to 13 squared. So our hypotenuse to be squared on the right hand side. And now to expand this bracket, there's always a way we can do this, which I can actually just write up here in the top right corner. And so this is going to be our rule for adding any two things together and squaring them once they're added together, and that is going to be up here in the top right corner. So we have x squared plus 2xy plus y squared, where x is the first thing and y is the second thing. And so we can use that now for x plus 3. So we can have plus, we're just going to put it in brackets again to keep it simple. So we're going to have x squared, the exact same as our formula. Then we're going to have 2xy, or 2 times x times 3, because y in this case is going to be 3. So that's going to be plus 6x. So hopefully that makes sense. And then our final term here is going to be 3 squared, which is 9. And so we can add all these things together, and then on the right hand side we're going to have 13 to be squared, which is going to be 169. And so now we're making progress, and we just need to basically work with what is now looking like it's going to be a quadratic. So we're going to have to deal with a quadratic here in a second, but we can start to simplify this now. So we can group our x terms together, or x squared terms, excuse me. So we can have 2x squared here at the start, then we're going to have plus 6x, which is going to be unchanged, and we're at plus 9. We can actually subtract across the 169 to get rid of that. So if we subtract across 169, our plus 9 is going to go down to minus 160. So we had plus 9 minus 169, so that's minus 160, and this is going to be equal to 0. And so the next step for quadratics like this, I think the best thing to do is always going to be to try and get rid of the number in front of x squared if you can. So we can see that we've got a 2x squared rather than an x squared, which makes it a much harder quadratic to factorize. But luckily we can divide across here by 2 and it won't result in any fractions. So we can simply divide across by 2, which is going to give us x squared plus 3x minus 80, 160 over 2 is going to be 80, is equal to 0. So now we're in a situation where we need to use our minus b formula. So I've just written that up here in the top right corner. And so basically the minus b formula is for situations where we have a number in the end which we can't factorize to give us kind of a sum or a minus, which is going to add up to this term in the middle. So we have no factors of 80, which are going to add up to give us 3, or add up to give us minus 3, anything like that. And so basically we need to use this formula, and so we just need to label a, b, and c. So a is going to be the number in front of x squared, which is going to be 1. B is the number in front of x, which is going to be 3. And c is going to be the number at the end, which we know is minus 80. And so now we can just plug these numbers into our formula. So that is going to look like this. So I'm just going to start simplifying it now. So we have minus 3 on the top, plus or minus the square root of 3 squared, which we know is 9, minus 4 times minus 80, which is going to give us plus 320. So that's going to be 4 times 80 basically, because the minuses cancel out. And then on the bottom we're going to have 2 again. And so we basically end up with x being equal to minus 3 plus or minus the square root of 329, all divided by 2. And this is usually where I just plug the number into the calculator to avoid dealing with decimals, because the square root of 329 is not a whole number. And so I'm just going to do that now. And so minus 3 plus the square root of 29 divided by 2 is going to give us this 7.57. And then we will take the negative case. So minus 3 minus the square root of 329 divided by 2 is going to give us this minus 10.57. So these are our two values, but actually only one of them is valid, and that is the positive one, which is 7.57. And so we know that x is going to be equal to 7.57. And so basically the reason we know that is because we can't have negative lengths. So remember, we got these values initially from being in a triangle, and so we can't actually have a negative length, and therefore we know the positive number that we got is going to be the correct answer for this question. So x is 7.57, and that is going to be it for this one.